$1 million a year set for a while. $100 million. Okay. Um, so Section 7, Section 8 are calculator-based problems, okay? And it's really important that you know how to use the calculator because you'll see these types of questions on the tests, and you'll need to know how to find certain things on your calculator. So part of today's notes is just you getting to know that calculator, be able to use the calculator correctly. That's why it's important to have a calculator today. And then the other is to be able to work through practical problems, be able to plug things in. There's two formulas that we're going to be looking at. And the first formula, I apologize, has a typo in it. And so we need to fix that up front here. This, in the exponent, it says r times t. It should be n times t. Okay? And so there's two formulas. There's that one, and we look about halfway down. We have this one. Okay? So these are the only two formulas that I'm going to be using in this unit. And how do you know which one to use? They're both financial formulas, but if you see that it's been compounded continuously, that's the only time you're going to use this formula. If it's compounded monthly, compounded quarterly, compounded daily, compounded once a year, then you're going to use the other formula. Okay? So if you start with this other formula, you can use calculus to show this, and you let n go to infinity, so you compound it an infinite amount of times, you actually end up with this other formula. So compounded continuously means you compounded an infinite number of times in a year, okay, if that were possible. So some of you may not even know what I mean by compound, so we'll back up a little bit here, okay? So when when you use this formula, you got a few different variables. So A is the money, the amount that you're going to get back. That's what you want, right? P is your investment, what money you're going to put in, and it's going to be a one-time lump sum. So it's not like you're paying every month or those kinds of things. Because if you're paying every month or those kinds of things, the formula gets a lot more complex. So we're just working with some simple formulas right now. R is the interest rate that you're working with. N is how many times in that year they compound the interest. And I'll talk a little bit about what that means in a second. And then T is how many years that investment's in. So in our first example here, a person invests $700 into an account that earns a yearly interest rate of 4%. And so if I'm going to use this, so 700 would be what variable? P, that's your principal. 4% is the what part of the formula? That's your rate. And you always have to change it into a decimal. So if it's 4%, you're going to change it to 0.04. 10 years is going to be the time, or in years, that's T. And then it says it's compounded once per year. So here we're not going to really talk about what it means to compound. On the next, on part B, I'll get into it because we're going to compound it 4 times a year. So just know in this one, n is 1, okay? Which means they're going to pay that interest out only one time that year, okay? So plugging this in, you have your amount is $700 times 1 plus your rate, 0.04 divided by 1 to the power of 1 times 10. Okay. So you can simplify this before you plug it into a calculator. You can plug it in as is. You each have different calculators, so if your calculators, you can't really see what you're typing in, you probably want to follow order of operations, which means parentheses first. So figure out what 1 plus 0.04 is. Which hopefully you could do that without a calculator. Then exponents, so you're going to raise that 1.04 to the power of 10. And then lastly, multiplication, you're going to multiply the 700. Now, depending on your calculator, you could type all of that in, and your calculator knows the order of operations, and so it can do that for you. So it really depends on the calculator you're working with. So let's all try it and see if we end up with the same thing. And I'm getting $1,036.17. So if you're getting that, we're doing the right thing. Okay. Now B says, how much would this investment be worth in 10 years if it's compounded quarterly? So everything's staying the same except it's being compounded quarterly. Quarterly means 4 times a year. You can think, okay, you got 4 quarters in a dollar, right? Now, if you compound your interest 4 times a year, what happens is you take that interest rate, so that interest rate's 4%, and you divide that by 4, which is 1%, okay? And you're going to pay out 1% 4 times that year. So at the end of the year, you end up paying out 4%. But what happens is you get a little bit more money because, say this person gave us $700. Well, partway through that year, they're going to get 1% of that. Now the money's gone up a little bit, right? And then they're going to get 1% of that new amount. So they're getting 1% of a little bit more. And then they're going to get 1% of that new amount. And then, so that's the compounding. And so at the end of the year, they're getting 4%, but it's not 4% of 700, it's 4% of a little bit more. So the more times you compound the money, the more you get. But it's not a lot more. And so we're going to see that here. So this would be 700, 1 plus 0.04 divided by 4, because we're compounding it 4 times. And so by the end of 10 years, you've actually, sorry, 700, not 70, yeah. You've actually given interest out 40 times, because you're giving out interest 4 times a year. So now you're compounded at 40 times, okay, over the 10 years. So again, try that one out. So I'm getting $1,042.20. You guys getting that? Okay. In a moment, I will give some time where I'll come around and check. If you're having trouble with the calculator, I do want you to speak up and I'll help you out with that. Okay. But I want to give some feedback first to see if you're doing it right or not. Now, how many of you have a bank account? Okay. Maybe Chase or EECU, or could be another bank too, right? How many know what interest rate they give you on your savings? Okay. So here we get $1,043.58. Okay. So compounded quarterly versus compounded monthly, you make $1 and something more. right? It's not a big difference, but it will always be more the more times you compound it. Okay. So we're just getting used to that formula. So I'm gonna pause. I want you guys to work ahead and try. Okay, so now this next one we're gonna compound continuously, so it's a new formula. It's the A equals P times E. It's not a base E, it's times E to the power of RT. Actually, I'll do A with you, and then I'm gonna let you guys try B and C, okay? So a person invests 500, so 500 would be what in that formula? P. 2.5%, that's your R, but you got to change it to what? 0.025. You got to move that decimal 2 places to the left, okay? It's compounded continuously, so that's the key word. Those 2 words right there together indicate we need this new formula. If it doesn't say compounded continuously, you go back to the other formula, okay? So we write an equation for this after t years. So we're just going to plug in t for t, okay? So we got A is equal to 500 times E. E is not a variable. It represents the natural number, which is roughly what? 2.7, right? And then 0.025 t. Okay, so there's your formula. Use that for B and C. Now, let me just tell you, C is the level that we want to work towards. This is the kind of problem that will be on the test. Okay? Because that's the problem that we're going to need logs on. And that's what we're studying. So first try B, then try C. I'm going to walk around. If you have trouble with your calculator so far, let me know so I can help you out, okay? Okay, so on part B, you're just plugging in 15. So you get to your amount is 500 times e to the power of 0.025 times 15. And again, when you plug this into your calculator, make sure you put parentheses around that whole exponent. Otherwise, it will just take the exponent of the first part, not both, okay? And what are you guys coming up with? $727.49. Do I have a second? Anybody else get that? All right, we're all good with that. Okay, now let's get to C. C says determine the time it will take for it to reach $700. So 700, where do I plug that in? In where? That's A. Good. So you're going to have 700 is equal to 500 times E to the power of 0.025 times T. And we got to solve for T. And we know we need logs because we're solving for an exponent. Okay? So now we just need to know the steps to get there. What did you guys try? Yeah. Divide by both sides by 500. And we can reduce that. 700 over 500 is 7 over 5. You okay with that? And so what's left? This is 1 e to the 0.025 t. Okay, so we got the exponent part, the e to the power by itself. What's next? It's kind of like what we were doing on the board, right? When we were solving for how did that 5,000 turn into a million? What was our next step? Change it to log form. So when you change it to log form, you take your exponent, so the 0.025t, and set it equal, your exponent will always equal the log. And this log is going to have a base e, so what kind of log is it? The natural log. You take the natural log of 7/5. Now we're almost there. Divide by 0.025, both sides. And you end up with t is the natural log of 7/5 over 0.025, and then the rest is up to you and your calculator, okay? Figure that out. And we're going to round to the nearest tenth of a year. So you should get 13.5. So 13 and a half years. Okay. So again, let me restate something I said prior. This is the level of the problem that you need to be working at, because that's what we're studying. We're studying logs, right? So being able to work with the formula, be able to use logs to solve for how long. Okay. All right. We got one more type problem at the back. Okay. It says an investment of $350 is made at 3% interest compounded quarterly. So here it doesn't tell you what formula to use. You have to decide which of those two formulas you should use. And if you're listening carefully, you should know which one to use. First one. Why not the second one? It doesn't say compounded continuously, right? So if it doesn't say compounded continuously, you're not going to use the second one. So we're going to use the first one. Okay? And so the first one was the amount is the principal times 1 plus r over n to the power of nt. And we're going to write an equation. So a is equal to, what would I write? 350 times 0.03 y over 4. Compounded quarterly, that means n is 4, good. To the power of 4 times t, good. Okay. Now careful, you want n times t here, right? Where the prior one was a little different, right? It was r times t. Here's n times t. So part B is just plugging it in. And again, part C is more like a test question that you might see. And it's going to be challenging, and I want you to try it. Okay, so try part B and part C. So for part B, what are we getting? $636.32. Okay. Now part C is now our Math 3 level type question. Okay. So determine the time it takes for the investment to double. Our investment is P, which is how much? 350. And if we're going to double our investment, that's the amount we want, which is going to be $700. And we're going to solve for T, right? Determine the time. We need to find T. So we plug it all into that formula. We get 700 is 350 times 1 plus 0.03 over 4 to the power of 4 times T. All right, so that's the starting spot. And solving this, anybody try to solve it? Anybody feel good about solving this one? Maddie, good job. Maddie, what'd you do first? Mm-hmm. Okay, so you're going to figure out what's in here? Okay, so I'm going to, we could do 0.03 divided by 4 plus 1. What did that come out to be? 1 point something. Okay, so I think that's a great idea. Okay, then what did you do next, Maddie? Okay, divide both sides by 350. And so this becomes a 1. And what's 700 divided by 350? 2, because it's double, right? And so we get 2 is equal to 1.0075 to the power of 4t. And now what? Anybody can help out here. You have to change it to log form because we want to solve for the exponent. So we got to get that variable out of the exponent. So what would log form look like here, guys? 4t equals log base, not 2, a weird looking base, but it is, of 2. And here's an issue, guys. Our calculator doesn't work in that base. That's not the answer. What was section 7 about, guys? Changing the base to whatever we want. Right? That's what section 7 was. So if we don't want this base, we can change it to something we want. Okay? So how? So I'm going to write 4 times t is equal to what? You guys remember changing the base? It's where this becomes a fraction. You need to peek back at section 7. Look what. So log base 10 of 2 over log base 10 of 1.0075. Or you can use natural log. You could use either one. Okay? I wrote the 10 there just to emphasize that there's a 10 there. You don't have to write that though, and your calculator doesn't have that. Okay. So now you're able to use your calculator, right? You can divide the logs, and then you can solve for t. And we're going to round it to the nearest 10. You should get 23.2 years.